Yeah. Say something you do want to be quoted as having said. Okay, I'll send a reminder just.
Okay, should we get started?
Yeah.
All right, so yeah, Smile. So Smile is a program we made internally to help us do experiments. Right now, what it does is just mostly help you program and debug your experiments and then upload it to a web server. And it has a lot of features that are designed to try to make the data quality that you get a little bit higher than a normal web form. So we like it. We've been using it for several years in various, like it keeps improving over time. So we have older experiments that use it a long time ago, and we have newer experiments that are using newer versions, but generally speaking, it's a better participant experience, we think, like because I don't know, it just looks like a more modern website. I think like people think like when they take part in a web experiment and it kind of looks like a weird 1990s form, that it's kind of like not that fun or interesting, and it's sort of like a little bit better to look at, they look professional. And then it's much friendlier developer experience. So like when I started doing this a lot, we talked a lot about how it's not substantively different from the perspective of a person doing the task, because like everything's just a web form and at the end of the day, but like for you programming, it can be like a much nicer experience. Which can be good because that means that like you make less bugs and are able to debug things easier and stuff like that. It's enabled us to make much more complex designs, I think, because certain kinds of psych experiments are actually kind of simple. Like if you're just trying to show people like a stimulus on the screen, I don't know if there's any real reason like why any other library like would be any better than this package for that. But like we tend to have like kind of complicated experiments like someone's worked on like the ARC challenge problem, and we've implemented a version of Smile and ARC. And it's a kind of a complicated thing with like grids and resizing, and we've had video games where people like grid worlds and it's multiplayer and people are interacting in multiplayer grid worlds, or Pat has like physics simulations going on, or Emily's done developmental studies that had quite elaborate like animations and stuff like that. So some of that stuff would have been very difficult to do without this type of technology, basically. Recently, really, it's only been in like the last like 6 months or something like that, like AI tools have, it turned out that the tech stack that we chose ended up being kind of like, it is one of the de facto pathways for web development now. And AI has gotten really good at front-end web development, basically. It might have even, when they're talking about solving programming tasks, I think that's the only one that they actually have probably solved, because it like really can do it well. And it turned out that the libraries we use are the ones that are like, some of them are baked into the system prompt of several of the models. And so like the models find it very native to write these types of programs instead of it being something very special or something. Okay, so the best way to experience it, we think, is to just look at the developer tools experience. So like what the main thing that is sort of a distinguishing feature is that besides being a thing that like helps you set up your experiment, code it, you get this like developer interface that that wraps around your task while you're working on coding it. It actually, all the logic of this gets stripped out before it gets sent to a participant. So like their package doesn't include all this extra stuff. But while you're working on it, you get more features. And this interface kind of, we think of it as like, I guess it's like developer tools that are more specific for this particular task. But like, so you're in this developer mode, you can pick different recruitment services that you're gonna pretend to come in as. Like, so if you're coming in from somewhere, you could come in from Prolific or come in from Cloud Research or whatever. You could add one for other sites like Spark or something like that. And then the reason that matters is because the URLs that people come from have like different special things on them. And so like it kind of, it tracks like which one you came in from. So let's say you do Prolific or whatever, then it kind of knows that you're Prolific. So you get this like overall display where your actual task is in this little sub window. It doesn't have to be there, so you can like press this and get it into the full space or zoom it back out. But this mode is kind of nice. There's some web browser tools that already do this, but this lets you see like what your task would look like on different devices. So sometimes that's useful to know because you're kind of developing your web form on one target platform, and it's nice to know if it's going to look terrible on another device, whether you want to like just totally discourage people. Like I know that like on Prolific, for instance, it will like let you say like, please only let people do computers. But it's still nice to know like, what does it look like if somebody opens it up on a phone? So like if we wanted to look at this one on an iPhone, you can see how it looks or whatever. Or if they rotate the screen, you can see like how it would look or whatever. Or you can kind of just see how it responds in general, And so like this thing of like being able to like make the things change like as the size of the display is called responsive design. And Smile does actually help both. Most of the built-in stuff is already responsive like this, like that it like scales nicely. So like you don't actually have to like limit people to like a desktop computer if you don't want to. So you can choose like different sizes or whatever. It also supports dark mode, which like for some types of designs, you may not want to do that because like, you might want it to all be the same color for everybody, but like kind of thinking forward a little bit, like I'm envisioning like kinds of experiments that like Smile might enable, like even future ones, like not the kind that we do right now, but ones in the future could include like, I don't know, like a programming task or something like that, like in the browser. And like, there's no real reason why we wouldn't want to make that like be the way that a person actually does program or something like that. So like it kind of lets you pick. And some people prefer to have the higher contrast thing or whatever. So you can disable it though. So you can make it be like it's only light mode or only dark mode, or it can resort to the user's system setting if you want. And there's a separate control for the tools itself. So it's like independent of that. Then the thing that probably is the most interesting is that like, okay, if you click over here, you get these like sidebars. It cycles through different settings of the sidebars. So the sidebar over here, I'll just put the one up because it's a little bit easier. Like this stuff is like kind of like helpful at tracking like kind of what your experiment's doing. So like one of the things that people use the most, probably the first feature we added actually was this like drop down, which lets you jump between different parts of the experiment right away. So like instead of having every time you reload and you start over and you have to click through everything again to go back to the beginning, you can just go like, I want to look at the Stroop part of the experiment, and it will jump you to the Stroop part of the experiment. Or if you like want to jump back and go to the demographic form, you can jump to the demographic form or whatever. So that's really nice for letting you focus your development time on the thing that you're actually trying to work on or whatever. And then you can pin a route. So I should describe this button really quick. So this button, this little lightning bolt, like resets the entire program, like sets it back to the way like a new subject just came in. It like forgets that it ever saw anybody. So when you click it, it kind of like jumps you back to the very beginning. But if you want to, you can pin like a route, like say like now you're like pinned to Stroop, like you're only going to be on the Stroop, and then if you nuke it, like it will like nuke everything, but then like navigate back to Stroop again. So it's like lets you reset things, but then go back to where you were. You can remember like which part of the experiment you're on. When you do a form, for instance, not only forms, but like most things like forms, like there's the ability to, like you kind of always have that problem of like, oh, I made this comprehension quiz and then I have to like fill in the answers, And some people like to do, like in our lab, we do a lot where we have a comprehension quiz. And then if you get it wrong, you go back to the beginning. And so we have to remember all the answers. So you can register like kind of a pre-fill values for these things just for debugging purposes. So like if you click this button, it will like automatically fill out this entire form. There's also a keyboard shortcut for it that's like Control A that just like if you just do it, if you do Control A, it will like autofill the current form. And like not every stage has that. So like if we went to window sizer, it's grayed out now because it's like this one doesn't really autofill. So like that also helps you like quickly go through, and it generates fake data that you can analyze or whatever in case like you need to see it or whatever. What other things to orient you to? The like this window sizer thing is kind of neat. So like it requests that the people make their browser window to be a certain size. And there's a setting that's over here on the side that says aggressive. And if you click it to be, if you take, right now it's on aggressive mode. After the subject says that they agree, like they agree that they can see it, you'll see over here, like these little toggles are like states that the application that is in right now. So this means that the person has consented to the task and they're a known user, meaning that they have like a database record tied to them. But they're not done, they haven't withdrawn, and they haven't viz, which means like haven't verified the visibility of the screen. So if I click, I verify visibility, now I'm visible. That means I indicated that I can see everything. But since it's in aggressive mode, like if you shrink the window size too small, basically it's like, we don't want you to miss anything, make your window big again. Aggressive mode off doesn't do that, so you don't have to do that, but it like kind of makes sure that you don't have people resizing afterward and then still being able to do the task. Like it just hides it from them and they don't do it or whatever. We like it for the, like we were saying, from the participant experience level. Once they get into the study and they've agreed to the consent form, they can always go back and look at the consent form again, you know, be reminded, or the contact information, if they feel something's wrong with the study or something like that, they can. And they have a withdrawal option, which actually gives them a little form that they can describe like why they're withdrawing, and to give you feedback if they want. This form doesn't have to be filled out, but then it just, you can say like, never mind taking it back, but it gives them a little prompting like why they're quitting the study that can be helpful to you. Like if they might say, I'm having a problem or whatever. And so those go away, like if we turn these into toggles, like we've simulated a person looking at this page now that hasn't consented, is not known, and so those toggles are not available to them until they like have consented.
Is there a log, for example, if they're resizing after consenting?
Yeah, there's, so like in this little part over here, like there's this is where the data stream that you got. So there's private data, which is like your worker ID and stuff like that came in. And then there's data over here, and I think there's one part in here called browser data. And it actually is a continuous tracking of like focus losing and all that kind of stuff. Yeah, that it records all the events that people do. It's currently empty because we reset it. But yeah. So these things help you quite a lot in like bouncing around and simulating different aspects of the experiment. This thing at the bottom here is the person who shows up originally. It's kind of is like an indicator of like where you are in the process. So this person viewing it is unknown. Like we don't know who they are yet. They're not connected to the database. If they come in and then they consent, then they're marked as like a known user because there's like a cookie inserted into their browser that sort of helps us know that they're when they come back. And then it connects them to the Firebase. It gives them a Firebase record that like is now where they're saving their data or whatever. And this little yellow thing is like every time like Firebase synchronizes in the background, storing the data every once in a while. You don't actually programmer actually do anything with that. It just you do it. It does it automatically for you, but it just tells you when the data might be out of sync at different points. Yeah, and so the Smile apps are persistent, which is another thing that is a little bit unfamiliar, which is that if you normally in like a web form, if a person reloads the page, it just re-executes all the JavaScript again, and so that it means that they'll just start over. So if you had a task that was a performance bonus, like a pretty obvious thing to do is to like do the task once and then press reload and then do it again. So you might get 2 data records or something like that, but like unless you're really checking out for that, like you're not sure which one to like analyze or whatever. So Smile actually tries to block that from people. So if I showed you an example, like if I autofill the form, I go to the second page and then I do reload in my browser, it just picks up like right where it left off. Mm-hmm. And that's true even for like trials of an experiment, like in this group block. If you go 2 trials in and you press reload, it'll still be on trial 2 of the experiment. It won't go beyond. And so that persistence is like stored in a cookie basically that keeps them and like keeps you in like where they're locked. So that little lightning bolt deletes that persistence. So like it just wipes the whole cookie away. So now they don't have a database or anything. They're back to normal again. And then you have to go back through the whole process in order to get back to it, to like enable the persistence sort of. So you can like navigate between the pages with these little arrows or whatever here, or jump between them or whatever. These little ones that are like have arrows next to them are called like sequential routes, which means like they're like parts of the experiment that come one after another. And then there's some that are like don't really have a natural order with them, like the withdraw form or whatever, like they like don't have, and you register that in a setup, which I'll explain in a second. But that's kind of like the basic overview. And then the other main thing to notice is the steps thing over here. So like if I go to a Stroop experiment, all the trials of my Stroop experiment are like enumerated right here. And what they are really is that like you can think of each trial of the experiment in this part as just being like metadata that's being displayed in a certain way. So like it's like the word that's being displayed or whatever. And so like in this little part right here where it says step data, on the first trial of the Stroop experiment, like what it's supposed to do is show the person the word Zamboni in the color blue. And then these are the steps of the experiment. So this is the second trial of the experiment, the third trial of the experiment. I can jump between the individual trials, like in any order I want, just to like go back and forth between them. And then if I click home, it'll take me back. But I'll describe it in a second, but this is like kind of like these are called steps, and you register your steps for your part of your experiment, and then you assign some metadata for them, and then you just pick how you want that to look basically for determining how you step through things or whatever. And then there's like a page over here, like, you're finished or whatever. And so the steps are nice too, because then you can go to like a specific trial and see like what went wrong in the rendering of that trial or whatever. For a simple experiment like Stroop, it's obviously not that big a deal, but like, I don't know, Pat has got like experiments where every different trial is like some complex physics engine, and there's like a lot of parameters about gravity and everything that are all being set separately. And so it does actually make sense to go to like the fifth trial and make sure that it looks correct or whatever, like, and how it might, how are there artifacts generated by that particular value of gravity or whatever. And so we use it quite a lot in that case, where you need to like debug a particular trial or whatever. And yeah, I think that's it. Info tells you some things like the last route that the person was on is the one that they'll reload to. The mode they're in is development right now. The project, the doc graph, this is a link to the Firebase document that is associated with that particular user. So you set up Firebase, and then this is where their data is actually stored on Google Cloud. And so you can find their actual data that way. Oops. And yeah, what other things are there? Right now, there's a document size limitation that Firebase has, which is about 1 megabyte per document. And right now, Smile uses 1 document per user, but like we have an partially implemented patch that basically like will remove that limitation and store the data across, break it across multiple documents and then recombine it. So like, but right now, when it tells you 1 megabytes, this tells you like how much percentage of that you have used up so far, in case you're debugging and you're trying to figure out if like my data, I'm running out of too much data or whatever. It doesn't become too much of a problem unless you're like sampling mouse tracking data at like a relatively high sampling rate. Yeah, so I think that's like the overview of like what this thing does for you. The panel down the bottom lets you view your data. It has like a little log that's kind of like the JavaScript log, but one nice thing is that you can set it to like only show you the messages from the last like page that you're on. So it helps you kind of focus your debugging effort on the part that you're working on. And then there's like configuration settings that you can kind of view through and edit or whatever. So so that's like what it looks like from the perspective of like the user, but or a developer. I just want to show you that you can run it in a test mode to see how it would look to a live participant. So if I run it in this different way, like this is what a real participant sees. So this has stripped out all that stuff, and none of that stuff is even delivered to their browser at all. And there's a couple other kind of neat things that it does with this that are like maybe worth mentioning or whatever. So like we tell them like a study ID and a version code, which is like basically the Git hash of the code that created, which is stored with their data file. So that way, if you ever have a thing where like later on you found out that there was a bug in the code way back, you would always be able to tell that data file was created with that bug producing GitHub code, which can help you. There's always like a track record that says data was generated with this version of Git. And users could send that to you, like a screenshot of that, and you would be able to like figure out like what went wrong for their particular version or whatever. The other thing that's interesting is that any graphics that appear in the page, like that brain or whatever, like stimuli or whatever, every time you build the website, it actually makes those be a random character name so that they're never cached in your browser or the user's browser. So like say like you had an image and it was like a certain image and then you updated it and like someone might have taken the experiment. Like imagine you did 2 versions of the experiment, you want people to come back, but you change one of the images and it has the same name. Your browser cache might deliver them the old version of the image. So what this thing does is actually always scrambles the name so that like every single URL is unique every time. So that way they don't ever they never cache anything. They always load from default root. But anyway, so yeah, so the actual user gets this like more straightforward page or whatever.
Did you do that randomization?
No, I didn't do that, but okay, so that's like the overview of like what the dev tool things get you, which is nice for developing and debugging and stuff. And then the part that I have those slides here. Then so how do you actually program stuff? So when you open the package, it's like a big GitHub repo. It has like lots of folders and stuff. It looks something like this, like there's a ton of folders. Most of the ones you don't actually have to worry about, like lots of it's just like built into the package. Like the only ones I like mention is that there's this built-ins folder, which has a bunch of built-in surveys, quizzes, and things like that are like already built for you so that you don't have to go design those things. And then there's UIKit, which gives you like lower level things like buttons and like drop-down menus and like little tiny elements. And then there's like user folders where you put your files mostly. So like you just kind of work in the user folder for the most part. And in particular, there's this one file called design.js, which is like probably the most important one, which is like the timeline of your experiment, like the order in which things will happen and some of the randomization and stuff. So built-ins give you all kinds of things. There's full documentation of all of them, but there's like, you know, a debrief form, a demographic survey that you can edit, a device survey. So we have a survey in most of our experiments that asks people like, were you on a cell phone connection, or were you on a landline, or were you like on a satellite connection, like just asking people about their general internet speed, like what kind of device they have. Even though that browser stuff can read it, like it's kind of nice just to ask people like what they were actually using or whatever, and whether they had a fast internet, whether they perceive themselves as having a fast internet connection or whatever. There's like a feedback survey, there's a thank you page, like all the little elements that you would need in a normal experiment are already kind of implemented for you. So design.js is like this long file that everyone has in it that defines a bunch of stuff of the actual overview. But the main thing that I call attention to is like right at the very beginning, it imports a bunch of things called views, like advertisement view, informed consent view, demographic view, or whatever. So what are views? So views are like the self-contained parts of the phases of an experiment. We call them views because that's just the name we came up for what it is. So like a consent page would be a view, instructions is a view, a thanks is a view. And you can mix and match them basically and reorder them because they don't actually have any intrinsic ordering to them. So the logic is self-contained in each view. And so you could like, you know, switch the order of anything without any additional code or anything. And the design.js file determines the order of the things. And then steps are the sequences within a view, like I was kind of showing you in that thing with the like Stroop example. Like the steps are like within a view, you might have like a sequence of like trials or whatever. So one way to think of it is like views are kind of like PowerPoint slides, you know, like they're like the big chunks of, and then the steps are like builds or animations that are happening like on a slide. And it's like kind of a straightforward way to think about it. So in design.js, the way we order our views is just by calling this like push sequential view thing. So we have a timeline object and we just say like add the demographic survey, then the window sizer element, then the instructions. We just put them in this like sequence like this. There's also some stuff for randomization and like choosing, you can have random paths and like random variables that determine your paths and stuff like that. It's all written up in the documentation, but for the most part, you just like define your layout like that. And then there's also at the top of the file are like what we call configuration options that are like runtime options that you can configure. So like, for instance, like color mode can be light, dark, or system. So at the top of your file, you can just say like, I don't want anyone to, I want it to always be light mode. You just type light mode at the top of your design file. So then the idea is that like design.js is sort of like a pretty clear summary of the like overall layout of your task and the configuration settings that anybody else could like read for replicability purposes, whatever. It's all kind of in one file. You just like read it and it's almost like linear. It's like, I had these configuration settings, I had this like timeline that I built up, and that's like what people would do. So how do you actually code things? Because that's all just like kind of configuration stuff. So in basic web design, right, most websites are an HTML page, right? And then they include at the top of them a thing that imports like some maybe JavaScript logic, like a library or something like that. And then some CSS that determines the styling, the cascading style sheet thing. That's this, and you put them in like one file. So like I've seen lots of examples on like OSF and stuff like that of people who do experiments with JSPsych, for instance, and like kind of looks roughly like this. Like they have a bunch of script imports at the top of their HTML file that pull in all the libraries that you need. And then you have your CSS files, and then you write in a really long like thing, your big task, right, in that one file, whatever. With frameworks like React and Vue and stuff like that, they have this other way of organizing it, which is this thing called a single file component. So there are files that end in a .vue, and Vue for Vue is what the framework that we're using. And what they do is they're a single file, and they combine the same three components, but just in a different way. So a Vue component has like a script section at the top. It's a bracketed set that's like script and script. It's like your script where it's like you put your JavaScript logic and everything up there. And then you put your template below, which is kind of like your HTML. It's like the structured layout stuff. And then you can include custom styling stuff at the bottom, like a style. And those are custom CSS classes and stuff like that that will apply if you write the word scoped, if you write style scoped, it will like only apply those CSS things to this component. So they're like locked to this component. So if you wanted to make like H1 font blue, it would, you could put it here in scoped, and it would like only turn it blue like in the context of that particular component instead of all of them. So that modular approach keeps everything kind of like clean and together or whatever. And I guess what the consequence though is that like the web browser still doesn't know how to read these files. And so what Smile does is the advantage is everything's broken up into little files that are individually writable and readable and exchangeable and stuff. But the consequence is there's a build step where it takes all of it and kind of smushes it all back together into like a really big JavaScript file and a really big CSS file. And not that big HTML file, but like, it kind of does that like for it. And it does that actually, the systems that have been written for that are like really intense, and they're extremely fast and they're extremely efficient. So they like beyond just compiling all the code into one file, they shrink it down, they rename all the variables so they have the tiniest names. Like, so if you had a variable called like Pat's experiment condition 1, it would be turned into like A in the delivery code, so that like when it gets sent across the browser, it's really fast and small loading. So it does all that stuff for you behind the scenes. Like you don't have to think about it. So it makes that's why I say developer experience is nicer, because you're coding in a smaller number, like you get to have smaller files that have more specific purpose. They're like more concentrated, but then the upside is that it does a build step where it builds everything to put it together. So the script section, like you import things, there's a thing called reactive state I'll talk about a little bit, and like logic. But it mostly just looks like regular JavaScript, like up here, like you just write your JavaScript there. And then the template section, you write like normal HTML, you have divs, you have buttons, you have inputs, all that kind of all the things that you normally have. It has a couple extended features that are not part of normal HTML. So if you have variables in your JavaScript, you can just insert them using this like double mustache thing. So you can just like, if you have a variable called like hello, the message can just like be injected right into the HTML directly like that, which is kind of nice. There are event handlers that you just write like this. So like if that button, if you want to associate it on click event, you just write @click instead of the way it is in low level JavaScript, which is like on click or whatever. And you tell it which function you want it to run. And then there are other directives like vmodel and vif and stuff that I'll talk about in a second. But so yeah, in combination with the like script section and the template, it's really efficient to like write like how you want things to look. And then the style section, if you write scoped, it will only apply to the current one, like I said. If you don't write scoped, it gets compiled into the global style sheet eventually. So one thing that's actually really nice for development purposes, but is a little bit maybe unfamiliar to people is like the distinction between declarative and imperative programming. So in a traditional JavaScript, when you're like, if you're writing with JSPsych or like other libraries like that, you're often doing a bunch of, you're telling the computer how to perform the updates to the display. So you do things like you write like document get element by ID to like grab a particular part of the web page. And then you like modify it in some way when some event happens, like when you click or whatever. But in Vue, you basically are just describing what the UI will look like and the template automatically updates. So when I write a template like this and I write count equals bracket bracket count, if the value of count gets increased, it automatically is reflected in the template without you having to like go and say like when the value updates, then do this. And so it just does it like smoothly. And so like that's why this button right here, this is like on a clicking of this button, increase the count variable by ++, and then count will just increase like when you do it. You don't have to like write all the rules for how you like set and get things, whatever, which makes it's kind of like this principle of like no code makes fewer bugs. Like you don't have the code that can go wrong, all the things that can go wrong in like getting and setting things. It just does it for you because you just declare it. So people are actually familiar with it because the best analogy is in Excel, right? Like in Excel, when you write a formula, it's a declaration. Like it says, like when you put the bottom of a column, you say like equals average these cells. If you change any of the numbers, then the mean automatically updates, right? You've declared that the cells average depends on the things above, and it recomputes anytime those inputs change. Like this is what this is like. It's like declaring how it works instead of you having to like, imagine how irritating Excel would be if you had to be like, if I change the value, then go down and redo the mean or whatever, it would like be unworkable. So it's like, it's kind of like, it basically does that. So normal JavaScript variables don't have that message tracking associated with them to know when their values are updated. So you have to just wrap them in this thing called ref. So if you make a thing, like if you make a constant variable constant, it says ref, it's not actually a constant anymore. It's const because it's a pointer to an object, but it's like count is now a dynamically living variable that works like an Excel variable. And so like whenever it's updated, its value will always change everywhere. And there's another one called reactive that does it for objects, but I won't go into the details about that. So like you see it here, it's like, this is the actual code for this button, like in a single file component. So there's a script at the top where it imports a button shape, more or less. And then it imports the reactive thing from Vue. And then it makes a variable called count and initializes it to 0. And then has a button where when you click on it, it increases the count. And then if I click it, it's just increasing the count like in real time. Like and so that's all you'd have to do to like create that kind of thing. So there's two-way binding too. So like here's one that's even more clear about how this would be a lot. So like if you can make a constant variable called text. And here I'm making a text input, and I made I think I deleted from the text code. It's supposed to have vbind. Oh no, vmodel right here is what vmodel is another shorthand for it. So here it's saying vmodel, so the value is kind of like value model for that input box is tied to the variable text, which was defined up here, like this text. And so then and then I also in the template I'm outputting like what you type. So if I have a text box here and I write like hello, then it's in real time like updating like even moment by moment. And but the code that I wrote is only that little piece. Like so like that's all you write. Like you don't have to write like a whole bunch of stuff about how to do the updating. Like it's just like you just define that like hello is tied and the vmodel passes it back and forth or whatever. So it's much more clear about what the code's doing or whatever. Just as a comparison, I wrote a JSPsych plugin that basically does the same thing, just to show, it's not that it's like, I don't really know that, especially with AI code, that it really matters that much, that it's like longer, although it is a lot longer. It's just like not super transparent, like what it is that you're trying to do, because and there's all kinds of things like here, like in JSPsych, when you write a plugin, you're often writing these HTML strings, like you're taking HTML and you're putting it in quotes, which means it removes all the syntax highlighting that you normally get on the HTML. Whereas like if you notice here, like the syntax, the Vue components know how to syntax highlight and even do version syntax checking on HTML properly to make sure that you end a tag and you put quotes when they're supposed to match or whatever. And it's really hard to do that when it's just raw string stuff. And so it like sort of becomes really hard as a programmer to like keep track of everything and make more complicated sites when you're having to do all this like manual layering or whatever. And then you can bring in, like a component can bring in other components. And so that's where you get this composition ability. So like if you have a component, maybe like a form, you can pull in a button and a text field or like a physics engine and a mouse dragging element or whatever. And then you can import them at the top, like in the script section, you imported another Vue component, and then you can insert that Vue component like somewhere on the page, like the simple button just gets inserted like this. This looks weird because it's like not valid HTML, like it's like this simple button is not a valid HTML tag, but like it figures out that what you mean is to take simple button means that you import this whole thing. And then if you go back to like when we had simple button over here, this template tag, it like inserted that template tag into that part of the web page. So it's like composing it up really quickly out of the pieces, basically. Make sense? So this is like, there are lots of great tutorials on Vue, like used by millions of people. We chose it partly because there's React. React's a little bit more popular technically in number of people that use it, but Vue is not run by a company. So but it's still very, very popular. So we decided to use that. And each component, when you import it like this, gets their own independent counter. So they're all like self-contained logic. So like if you put two simple buttons in, each one has their own counter or whatever. The template language for a component is augmented with a couple other little things that are kind of neat to see. So one of them is called vif. So if you have a div or any element and you write vf and you have a true false or something like that, it only shows that div when the message is true. So that lets you quickly toggle hiding things, like you can show and hide an element of your form that way. It also has a method v4 where if you have something like a list rendering, it will like let you create like a list item for a bunch of things, like a set of bullets or whatever, that are built into the template language. So you don't have to like unroll those yourself with a for loop, which is a common thing in most templating language or whatever. So how do you make a quick experiment in Smile then? So we'll build a simple one from Stroop from example. I'll just like walk through it. So we start off with a completely blank Vue, a pretty default Vue component. It's just got a script section, it's got a template section, it's got a style section that's empty. The template section right now just has in H1 says like my experiment. And at the top, it imports the API for the whole package, like use the API is the API that's used for the whole Smile thing. So then we're going to use api.steps.append to define the steps of your child. There's other commands, but like you can use append to do it. So like if we wanted to, we just do like API steps.append, and this would be 4 potentially trials of an experiment, let's say, with different words that are displayed or whatever. So that's all we do at the top to set our code up. And then then we want to like actually display the word. And so the way we get access to the current step, like as the steps go through, it's going to point to a different element of the step. So we just use api.stepData, gives us the current one you're looking at, and .word on that is like the property that we defined. So that's going to let us like show the specific word that we're presenting each time. So we're almost there, although right now it's just going to show us like the first one because it hasn't got any logic for advancing through the steps. So there's a on key down listener. The go next step will be used. So like if we insert here that we're going to do on key down, if you press a space bar, that's registering what key you want, then go to the next step. So API.go next step, it just advances to the next step of the stepper. When you do that, and this will automatically update when that happens so that it will just step you through the trials one by one like that when you press spacebar. So it's like that's basically a trial, like, and then you just make if you wanted to make a more complicated experiment, you just make this data structure more complicated. Like Pat's experiment has tons of gravity parameters and whatever. And then his template's much more complicated because it has like a lot more logic of like what it should look like. But more or less, this is the like basic thing. And then we can add like a timer. So Smile provides some like timing things. So you might want to like start a timer when they start the trial or something like that, and then measure the elapsed time. So we'll just insert here like starting the timer. So we'll just like API.startTimer. We'll start a timer when that loads. And then if every time the key down happens, we can like do API.elapsed time, and it will elapse the time since the last time that timer was started. And we could store that in a reaction time field of the step data, and then go to the next step. So that's recording time. You can make name timers if you have multiple timers. If you pass a name in there, it will make like multiple timers for different things, different events. And then the last step is we just have to write API.record step, and that will like save all the data from that particular trial. Now it doesn't save it to the database right then because Firebase can't write like that quickly. Like it's got a 2-second window. So like Smile has a bunch of logic to buffer the data and then save it when it's next time it's convenient, basically is the right way to think of it. But you don't have to worry about it. If you type record step, it's either going to be saved in the like local storage of the browser. And so if the person reloads that data will still be there. It won't be lost. But then also like as they advance through, when it's an opportune time, Smile will make a decision to try to like save the data to the server. And it saves it incrementally. So you'll get like partial data. If someone were to quit halfway through or whatever, they'll get as much of the data as they can. Yeah.
Is it possible to save like a lot of steps? So like import them from a CSV file or something like that?
Yeah, totally. Or like, I mean, an easy way, you can do that for sure. There's like a library that will load CSV files that you could add, but when we need to do that, like you can just write it in a JavaScript object. It makes it a little bit easier, just translate from CSV in that, and then you can just import it at the top here. And then it will, at the time of building, it will basically insert the CSV file into the JavaScript, into the file. As long as it's not super big, if it's like if it's, yeah, there's a choice there. Like if it's megabytes, you might want to load it dynamically at the time. But if it's just like 5,000 entries or something like that, even, it would probably be fine just to like put it into the JavaScript directly in a separate file though. Yeah, totally. So then you, record step and you're done. And then the last step is like how you have to like go to the next view because you're done. Like when you're completely done with this thing, you have to transition out of it. So there's a property is last step that detects when you're on the final step, true or false if you're on the last step. And then there's one called go next view, which like instead of go next step, it's go next view. So it will transition to the next view of whatever order the things are defined in your timeline. So we'll just add that here. And so like if after we record the reaction time, if it's the last step, then we'll go to the next view. Otherwise, we'll go to the next step and continue within the current one. So then you're done. So like that's basically like trial structure. There's more fancy stuff you can do. You can have hierarchically nested steps for various reasons. Like there's lots of things that you can do, but like this is really just like the most basic structure. So then once you have your little component that you just wrote, you might call it something like my view and put it in your user folder. Then you just go back to your design.js file, you add it at the top, like import my view from @user, add as a shorthand for the source folder. So it's like @user components my view, and then you just push it onto the timeline. And now you've taken that current structure that we have with the consent form and everything, and you've just inserted your experiment logic in. And so you really just work with that one file and just put it into the timing wherever you want. And then you're done. So then npm run dev is the command that I did to create the DevTool version. And so it will show up in the DevTools and you can start working with it. One thing I didn't show, but it's kind of neat, is that it does live reloading during development. So like if you got your editor open and you have the DevTool thing open and you make a change to the code, it will seamlessly just update in real time. It doesn't even reload the browser. It's like more fancy than that. It reloads the component tree that was modified. And so you can like you can really go back and forth. You can go change it and it'll update really quickly.
When your patient comes to your timeline, can can you add like conditional statements in there? So like if someone didn't hit a certain accuracy in that view, can you like loop it or like?
Yeah, so like the different ways of programming it, but like one thing that you might do, go next view goes to the next view. But you can also go to view to a named view, and so you could like go to instructions. So you could like compute and go like, oh, they didn't pass, like go back to the beginning or whatever. Yeah, exactly. You could have them go wherever, yeah. There's another function for that. Yeah, and then the GUI shows you, so you can steps, you can visualize stuff. If you type npm run dev live, you saw what I did, that shows you like kind of how it will look to the final subject. If you just want to run through it that way. There's also this mode that is kind of neat called presentation mode. So if I do npm run present, then I get a different version of it. And this is like basically makes like a web page that you could send reviewers or people to, which is kind of like the dev mode, but a little bit more low key. So it's like, it's got a little page here where you could put some graphics and intro and authorship information or whatever. And then it gives you like a thing where the people could jump around in the task in the same way. So they can jump, like if they're here, they could jump around just like they would in the dev tool thing. So that's kind of nice, but you could also call their attention to, hey, reviewer, if you wanted to just jump to our instructions, like click this button and it will jump them to the instructions, or here, just do our task, skip the instructions, just see what the task looks like, go here. And you could modify this and change it yourself, but it just sort of gives you initial version of like what this looks like. And the way you can deploy your project with this front end instead of the other one as a way of, if you want to quickly build a public site that lets collaborators and other people like see the site or whatever. And then when it actually builds it, and this live thing runs it in dev mode live, but when you actually build it, you write npm run build, and that does the assembly of all the files into an HTML directory, which is the dist folder, which is not tracked on GitHub, and then this is where all your files are. And if you look at it, you'll see it's just an index.html file and a bunch of weirdly named .js and CSS files, because it breaks it up into like tiny pieces so your browser can thread it and get like load it really quickly and stuff. So it does a bunch of efficient stuff, but it's basically just the same as a normal website at the end. It's just been computer modified to be more efficient on loading. And then the last thing that Smile does is help you deploy your experiment. So like the steps are, it uses Git basically, so as the tracking thing. So when you're working on your code, you have your project, you have a GitHub repo. Every time you push a change to it, it will automatically build your project given the current setting of the code and upload it to a web server. And then it notifies your Slack channel in your lab to let you know that like it got done and it was successful. And so that means that you don't have all that stuff of like, did I deploy or update my files, or did I drag them to the FTP file onto the web server, or whatever. It just does like, as you push, you get a new deployment that copies. They sometimes call this like continuous integration. It just kind of continuously is updating and publishing your stuff. So like if we look at my lab's Git, like we have a special channel that's called Smile Deploy. And every time that anyone's working on stuff, they get this little message that's like, hi, Garekus just deployed an experiment to this URL. You can click it. It gives you the GitHub hash for that commit. And so you can look at it. And then, it's kind of nice as a PI, I guess I like see what everyone's doing. Like I can see like, oh yeah, everybody's like working on their experiment right now and making changes to it and like it's coming through or whatever. And then you can see like where you're supposed to click to like open up your task or whatever. See like, who's this one? It might be mine, but yeah, it just jumps over. So yeah, so you get push, it builds your site, it uploads it to the server, and then you get the Slack bot. You configure it once for your lab. So like instead of because like there's a lot of things here like Slack and everything. You do it once for your lab. It's a little bit of a couple services. You got to do Firebase, you got to do GitHub, you got to do Slack. But once you get all those in, you get these files and you just keep them on a lab server or like in a Slack channel or whatever. Any new person can just start a new Git repo based on Smile. You give them the keys to your lab, and then they'll start going, and their data will all be segmented off into their own little area of everything, but you won't have to like reconfigure everything again. So one person can like set up your lab for once in the Slack and everything, and then you just share those files with everybody else. I won't say much more about that, but it does do one nice thing. It anonymizes the URL. So you'll see these weird words on your project page. It's called like hike, shark, kite. It's 3 random nouns that have been chosen for every project. And that's so that when you send your subject to the URL, they don't get something like emotion regulation study as like the title of it, or like false condition or something. Like it just tells you like it gives you a random code, so like it's kind of like, I don't know what this is, hike, shark, kite, who knows? Like, you know. And yeah, so you need GitHub, you need Google Firebase. Google Firebase does cost some money, but it's never cost us for like everyone using it more than, definitely less than $10 a month to do it. Like, I think it's like $8 or whatever. You need a web server. Sadly, universities just used to provide this for everybody, but they don't really anymore. So we use DreamHost. It's like $3 a month, but there's other ways of doing it if you have a SSL server for a web server. And then Slack, you don't technically need Slack. You could delete it out, but it's kind of nice to get those little messages when your project was like correctly just sent into the cloud, just to know that it's there. You could change it to email you instead, or use some other service or no. And then these are the 3 files that you configure once and then share with everybody. They go in the .environment folder, and so they're not tracked by GitHub by default. Those file names are ignored, and you just like take those 3 files and just put them someplace that everyone privately in your lab has access to, like your blog or whatever. That's it. So you can try it out. Maybe it helps, maybe it works. And we're happy to give advice. There's like a discussion forum that I guess would be our preferred place for asking questions publicly on the Smile GitHub page. There's like a forum feature in GitHub now. And if you find bugs or anything, you can create an issue on our GitHub repo. And then there's a feature roadmap that shows some things that we're planning. I think one that's I think kind of interesting is that like we've kind of already piloted like a dashboard that would let you see all your data as it comes in as a separate part of the dev tool thing. Like there'd be another panel and you would go to that and it would show you like all your data. And that will expose some things that we're secretly doing kind of behind the scenes, like kind of what you're asking about, like window switching and stuff. That's all being tracked, but sort of it's up to you to analyze it. But we're going to try to make the dashboard be like front that a little bit more. So you could like, it would give a flag and be like, this subject changed window focus more than 3 standard deviations more than a normal user did, or something like that. And so you could like use that as kind of a quality assurance check to be like, oh yeah, this subject might be suspicious for this reason, or something, or they type too fast or whatever. So we want to add features like that to like make it so that like there would be this overview of your data as it comes in that also expose some quality assurance features about like how people were using the app that would be on the side of it or whatever. But yeah, I think that's it.
I have a quick question. Sorry to go over this in the documentation, but like if I want participants to play a game that has some Python logic, is there a way to integrate that in your existing code? Or like what it might be the steps to start?
I mean, there is a way to do it. Like if you Smile can call a normal AJAX request basically to a server. So if you had another server someplace, you could just like, do you have your Python server located someplace? You could call it that way. That would probably be the best recommendation, especially if your code is too hard to translate to JavaScript or something. But
We'll have done like this exact thing, like a task that they wrote in Python that runs on a server that they still want people to do, like with JavaScript. I've seen like that guy Will Carvalho who was here recently has a thing like this, but it is like a tiny bit annoying. It's like you can't go super fast because there's the entire ping back up to the server and back down. So you can only have like 1 move per second at the fastest.
Okay.
yeah, that's like if someone wanted to do a grid world, like
Yeah.
a decision-making task like that, then you could do that, you know. But we've done multiplayer games where, as it turns out nowadays, I think you can translate the code from JavaScript to Python pretty easily. So you could like write your Python logic and just ask Claude to like translate it and make a couple tests to make sure it's functionally equivalent. And it would not take that long to re-engineer it that way.
I was just about to ask about multiplayer games. So how do you, like, is there any support for kind of matching participants and?
So we haven't put that into the main tree, like we've done experiments that use multiplayer things, and we have like a little waiting room component that like waits for the people to join and stuff like that. It uses a slightly different feature in Fire and Google Firebase than the one that we're using. Like we use Firestore for the data, but like there's a thing called real-time database that lets you, does like streaming push and pulls, and we've made experiments like that, like so. We've had multiplayer experiments that they can't be super fast. They're not like, they wouldn't be good for like joint action tasks with like motion. But trial-based ones, like you take a turn, I take a turn, are totally fine. And I think you can get it down to like maybe a second delay or something like that. But it's like, I don't know if it would work that great if you had like two people controlling a mouse at the same time. But you have to look for another, like you have to use WebSockets for that basically. But yeah, we haven't, that's on the like future list. I think we have a roadmap that has that in a, like maybe a couple of versions or something like that, where we would like support that like fully as a feature, but we've done it. It's possible. It's just like, just like all this stuff is like very like purposely built with, to be clear, but it could be, that one is like an add-on that we did custom.
So in terms of stimuli you can use, like we use a lot of music and audio stimuli, is that possible?
Yeah, totally. Yeah, totally. Yeah, I mean, when the front end part, there's some stuff that we help with, but for the most part, the nice thing is that this is just a normal node package. So like if you wanted to do an audio component, there might be some nice audio playback components like already built that'll work with this ecosystem, and you can pretty much just install them. Like you just type npm install, you just like look on node package manager, and it'll probably be like some amazing audio player or whatever. Although most browsers can just play it. Like you just make load a sound and play .sound or right.
Yeah, I've done exactly this, super simple experiment that just played a sound, and it was just the default JavaScript, like new sound, and you get the MP3, you put it in the folder, and it's just like normal. Yeah.
Yeah, it's not hard, but there's also like, yeah, if you wanted to have video playback or like fancy stuff like that, you could definitely do like more complicated things.
And then in terms of like interactivity on the site, if we're having them like rate something and we want to track what they're rating, is there a way to like export? Like, I know you said that there's the way to keep track of like if they change or go out of the window, come back in the window, change sizes. Is there a way to export that information to like a CSV or Excel or?
Oh, yeah. So that, well, yeah, so I didn't talk about that right this minute, but if I go to the docs, it's like smile. There's a section here called like analyzing data. We have a command, you just write npm run get data, and it gives you a little interactive script that will step you through some questions about what data you want to download. It doesn't put it in CSV, it puts it into a big JSON structure, I think. And then you can parse it however you want, yeah. And so like, yeah, you could make there already is like a slider, but you could make a custom slider and it could record every little motion of it. Like the default one probably just records like the last location that you put it in before you set the form, but you could make one that's like continuously monitoring it and just store all the data in your step data and then just save it. Yeah.
And that's only for slider data, or would it also be for like buttons on the like key presses on the keyboard?
Anything like that, yeah, you can do anything, yeah.
First of all, this is amazing. I can't believe you and your lab built all this. Looking forward to it.
It's like 99.9%.
Yeah. Well.
I think I changed the color of the error messages.
Okay.
Like,
I think I saw you working on some tools, like a game to prevent AIs from filling in answers and pretending to be participants. Is any of that implemented?
It's not right now, yeah. There's some basic versions of it, but yeah, I think that like there's a couple things already embedded in it that are like kind of like that. So there's like a couple of the forms have hidden form elements that they're not visible to humans, but if a AI was reading it, might fill out the form. So they're called honeypot traps, where you basically like have a thing where the AI might fill it out because it just like goes like, oh, fill out all the form elements. And so like there's things like that. There's things about like making text boxes record the intertrial interval of like typing, because there's like a characteristic typing speed, and like if you're cutting, pasting, or streaming from a language model, it'll be different. There's stuff about scrolling, like the cursor clients that computer control ones, they scroll really like robotically when they use web pages, and people scroll smoothly. So like, yeah, I think we want to add those things, and that would be part of this dashboard feature where like they would essentially be like, there'd be all your data would be like rows. And then it would have like this little, like, I'm thinking like a little bot score that would be like sort of like, take several factors, like, did you pass the comprehension quiz? Did you fill out any form elements that were hidden? Did you scroll weird? Did you type weird? Did you zoom back and forth between a browser a bunch? And it would kind of add those up and give you a score that was like, I'm not saying you're a bot, but like you're like, you're kind of odd relative to the rest of the data set with respect to that. And then, and there would be, yeah, a feature, but we've inserted into the running app a lot of little things like that already. And I think like, we never really like analyzed them, like nobody really like got into analyzing those features, but I think like the next version is gonna essentially be like,
And
Add that.
you could just make it hidden form on your own.
yeah.
Okay, and one more unrelated question, I guess and server stuff is always a mystery to me, but so why can't you just put this on your like NYU web page, web space, like you can't just put the files there and.
You can, no, you definitely
Direct.
can, you can, yeah, if you have access, so the thing I understood is that NYU canceled this thing called NYU Pages, which was like a web hosting service where you got like a little folder you could write to. The reason why you could use like GitHub Pages directly, like, your classes or whatever, you have that thing where it copies over. But like what Smile does is make a new folder for every branch of your project, and you can't make subfolders in GitHub Pages. It's like a limitation of it. So you need like a directory where you need a web place where you can write folders. And it's like really weird, like as an old guy in the web, that like this has become like a bespoke feature, because like, but nowadays people do web apps where they just like write an app and then deploy it. And they don't need folders because they just sort of like one-to-one map their app to a URL. And so you have to find like some service that still provides you like a writable disk that you can put folders in. So it could be anything though. I mean, you can do it on Raspberry Pi, you can do it off of, yeah, I mean, NYU or Princeton, I'm sure. NYU used to have stuff like that. I think they just,
Well, we all have like directories with you can store, like personal web page or something.
no, I think they canceled that, yeah. I mean, you might have it, the Sims one, but like Kron does, but like NYU, the MBM page was on this thing called Pages, and then they wrote an email and were like, we're canceling the service because we're like, can't afford to pay for it anymore. And we had to go find a different solution. So like in theory, yes, I mean, you could talk to the tech people and be like, yeah, psych.nyu probably should be able to write to it, you just need a folder, but like, yeah, I mean, you can technically serve it off of your, yeah, there's several ways to do it cheaply, but you don't need to set up a special service for it. You could probably just use one if you can find one.
I saw in the documentation that you can randomize conditions, but I was kind of curious where in the workflow that happens.
Yeah, it's funny because I haven't used that randomization stuff as much, but the randomization stuff happens in the design.js file. So like if I go to the source user design, there's one example here, I think, where you call this random assign conditions, and there's like, for instance, there's like could be 3 instruction versions. So this creates like a random variable called instruction version that has 3 settings and it has weights associated with them. You can make one more popular than the other, whatever. And then I think in the instructions view, inside the instructions view is some logic that like checks which instruction is supposed to display and then uses that random variable. And then the design interface provides you with some overview of all the random variables that have been defined in your task that way. So like you go over here, random, these are the random variables that have been set in this particular experiment, and you can force them to have the other value than they would have. So if you go to instructions, and then it's randomly been set to instruction 1, but you can do instruction 2, and then you can see how it's doing instruction 2 or whatever. So those are random variables that get defined. They're kind of in your design. It's almost like you sample like a binomial or whatever at the top. And then it propagates down through the whole tree. And then you can make conditional branching too. So like in the timeline, there's something here in the timeline, but like you can make, instead of having just linear timelines, you can have like like 2 different ways of getting into one. You can have conditional branches that like if you're in condition 1, you go down this path. If you're in condition 2, you go down this path and stuff. They're all defined in this like timeline document. It shows you how to use them.
Is there support for like multi-day studies or like longitudinal studies, things like that? You would have to read from Firebase, right, to you?
Yeah, like depends what you want to do. If you just wanted to like connect the people twice, I think it would just be a matter of like they have the same user ID. Like presumably if on your server you would have some common ID.
Yeah.
If you wanted to read their data from before, you would have to do a little bit of work for that because for privacy reasons right now, each subject can only read their own document. So I'm trying to think how we would set that up if you came back. I guess you could get your own document again.
Unless you've cleared your browser
Unless you
cache.
cleared your browser cache, yeah. There'd have to be a little bit of work thinking about how to do it, like where you got access to your data from before. But it's definitely not like insurmountable. It'll just require a little bit of
Yeah,
work.
more tinkering.
Yeah. All right, cool.
Okay.
Right.
Thank you.
Yeah.